Hello, everyone. Thanks for joining today's episode of Datadog On, where we're going to talk about OpenTelemetry. My name is Juliano. I'll be your host today. If you don't know what Datadog On is a series of episodes where we interview the engineering team of Datadog, and we discuss with them challenges and contributions that they are facing within Datadog and with contributions on the open source world, things that they are problems they are solving, issues that they are facing, and implementations that we actually applied within Datadog. And we try to bring engineers from the teams that were involved in this solution to present their solution and discuss with the advocacy team, the team that I'm on, to share this with the broad community and share from engineers to engineers what we are doing here at Datadog. All the episodes are recorded and posted later in datadogon.datadoghq.com. So if you want to take a look into the previous episodes, we have the link there. Today we're going to talk about OpenTelemetry, and we have two amazing guests from our engineering team. I'll let them introduce themselves in a second. And remembering everyone that we will have some Q&A at the end of the session. So if you have questions throughout the episode, feel free to raise the questions on the Q&A session, and I will bring the questions to everyone whenever we get that at that point. If you don't know what Datadog is a monitoring and analytics platform that helps companies improve observability and security of their infrastructure and applications. And just to give you an idea of Datadog's scale, we have 20,000 plus customers. We monitor millions of hosts, and we have tens of trillions of data points. We receive those trillions of data points per day. That's all that I have to say about Datadog. Let's now focus on the episode and OpenTelemetry. So, well, as I said, my name is Juliano. I'm a technical advocate at Datadog, and I'm focused on OpenTelemetry. Besides that, I'm also an OpenTelemetry demo maintainer. So if you have ever seen the OpenTelemetry demo, I'm one of the maintainers of that project. Together with me today, I have Felix and Pablo. I would like them to introduce themselves. So Felix, hi, do you want to say hello?
Yes, hello. Should I introduce myself, or are we doing
yes,
that in
please.
a second? Okay. So yeah, hey, I'm Felix, and I work at Datadog. I wear a bunch of different hats as a senior staff engineer, but I guess my home base is the profiling team, where we're building the continuous profiler product. My technical expertise there is especially on the Go runtime, where I've also recently become a contributor, sending patches upstream and working with the Go team at Google to improve observability in the runtime, especially around profiling, but also around metrics and other things. And then I'm also a member of the OpenTelemetry special interest group that's defining the upcoming profiling signal, which is why I'm on this episode today and what I'm going to talk more about later.
Awesome. Cool. And we also have Pablo here. Hey, Pablo.
Hey. So I'm Pablo. I'm a senior software engineer at Datadog. I work on the OpenTelemetry team from the engineering side, making Datadog and OpenTelemetry work well together. Then I'm also involved in the OpenTelemetry community, where I maintain the OpenTelemetry Collector and do a bit of other stuff like semantic conventions and helping with the contributor experience.
Awesome. So I guess that if you joined the episode on OpenTelemetry, there are two types of people that are joining: the ones that already know OpenTelemetry and the ones that want to know more. So just to give everyone a primer of what OpenTelemetry is, I'll just go over a couple of slides and then we start this discussion. So let's start with what OpenTelemetry is. So if we could sum up in 3 bullet points, it would be that OpenTelemetry is an API and SDK for multiple different programming languages. So it is a collection of APIs and SDKs. This is consistent across those multiple languages, and they can be configured and on the same way in all those languages, either via a config file or environment variables. And it's important to follow what we in the project call a set of semantic conventions. So this define also a common language across those different programming languages. And we also have a set of tools that can be either the OpenTelemetry Collector that we will mention in a sec, what it is and what it's used for. We also have the OpenTelemetry Collector, the operator that is used by the whenever you are deploying OpenTelemetry in Kubernetes. And I would even say that the OCB, which stands for OpenTelemetry Collector Builder, is also a tool provided by the OpenTelemetry project to build custom collectors. Just so you have an idea of how important OpenTelemetry is becoming, the project is being adopted by Kubernetes and gRPC. So those are already well-known and stable projects, and they are adopting OpenTelemetry as their default telemetry tool. From the OpenTelemetry page, what OpenTelemetry is. OpenTelemetry is focused on the generation, collection, management, and export of telemetry. And in the official OpenTelemetry docs, they also try to focus on what OpenTelemetry is not. And OpenTelemetry is not an observability backend. So that's where Datadog and other vendors come in. So you use OpenTelemetry to generate and collect or produce the data, but you still need somewhere to store, process, analyze, and give you value out of this data that you have now that you are collecting. So that's where we have Datadog. With OpenTelemetry, you can produce different types of data, and within the project, we call that signals. We have, as of today, 3 signals that you can produce, and it is already supported widely, which are traces, metrics, and logs. And something that we will discuss a bit in this episode is the new kid on the block, profiling, and how profiling is making its way into the OpenTelemetry project. So now I want to bring the focus of the episode is the engineering part of OpenTelemetry and the engineering part of OpenTelemetry at Datadog. That's why we have Felix and Pablo here. So I want to start with Pablo and talk about how OpenTelemetry is used and implemented, or even like what are the roles and responsibilities of you, Pablo, within the OpenTelemetry project. And sorry, before you start, as I know that you will mention the OpenTelemetry Collector, would you be able to give the audience a little high-level overview of what the OpenTelemetry Collector is and why would I use it?
Sure. Right. So the OpenTelemetry Collector is an application that you can run on your infrastructure and allows you to create data pipelines for the different signals that you mentioned before. So you are able to receive, process in some way, and export traces, metrics, logs, some profiles, and it covers a wide variety of use cases. You can use it with commercial and open source solutions. So you could receive, say, metrics with an open source solution like Prometheus. You can enrich those metrics in some way with a processor, and then you can export it to a backend like Datadog. So my main role within the OpenTelemetry community is as a maintainer of the collector. That means that I set the general direction of the project, decide what's in scope and out of scope, and define both the general framework for the collector as well as have a say on the different components that you can use in the collector. These the ones that we see on the slide: the receivers, processors, connectors, exploiters. And as I said before, I also have some participation on semantic conventions, which is standardized way of adding semantic information to your telemetry. So things like specific tag names associated with a given meaning. Well, the main thing I'm working on right now is getting the collector 1.0, which I guess we'll talk about in a bit.
Awesome. So you mentioned this road to the collector 1.0. Would you be able to give us some ideas of what are the current challenges that you're facing and why for the community having the collector as 1.0 is important?
Right. So the OpenTelemetry Collector is used in production and at scale, but by many users and companies around the world. But something that we are lacking today is stability. So we follow semantic versioning, and like right now we try not to annoy your users too much, but we do make breaking changes from time to time. So this has been something that the community has wanted for a long time. The first time that this discussion was started in some way was at the very end of 2022, but we got seriously working on this at the end of last year of 2023. And a big motivation was a survey done by the end user special interest group, in which we could see that collector users did care a lot about stability, and so this is something that we should focus on. So we've been working on this for the past year. We published a roadmap in May and a blog post explaining what we were set to do. The scope right now is relatively focused, and so what we are aiming towards is to have stable behavior on the application that our end users use, and have a few components stabilized and marked as 1.0 as well, and signal this with a new distribution that allows for a sort of narrow set of use cases. And with this experience, we hope to learn how to continue working on stabilizing more components and continue doing it with the rest of the community as time goes by, so that users get what they want.
Awesome. Cool. So we have the collector that's been within the project since I think the beginning. I think I started using the OpenTelemetry Collector when it was version 0.36 or so, and we are just on version 0.109. So yeah, I'm pretty excited about the collector 1.0. Looking forward to that. But now I want to bring Felix to the discussion, because like Pablo is working on something that it's being within the project for a long time. I think since OpenTelemetry was a thing, but profiling wasn't that. So Felix, would you like to give us like a little bit of history class on how the profiling became a thing and how the discussion started, and what is the state that we have as of today? Can I start already using profiling?
To disappoint there, not quite yet, but we're getting close. But let me tell you a little bit more about profiling and OpenTelemetry. Basically, profiling has recently emerged as sort of the fourth pillar of observability, where a lot of people have realized logs, metrics, and traces are sort of the baseline that have been proven to be very useful for people to understand what their systems are doing over time. But there's a few use cases where these signals are not quite fitting the bill. And in fact, the story for OpenTelemetry and profiling goes back to October 2020, when Sean Marciniak, not sure if I pronounce this correctly, his alias is easier, movie store guy, he made a proposal to OpenTelemetry to introduce profiling. And the use case that he outlined as a good use case for a new signal is things that are hard to instrument. And the example he gave was mutex contention, where you have something that is maybe in a very hot code path, such as a mutex protecting a critical section of your code. And you probably don't want to emit logs for every mutex contention. You probably don't want to do a metric that seems heavyweight. And certainly distributed trace would probably be way overkill. So you needed something that would allow to instrument these common contention points, of which there might be very many in a big program. And so that was the example. The other example I would say is things that are hard to predict that you would even want to instrument them. So for example, you might have some innocent looking code that is a for loop, maybe nested with another for loop, and normally things are really good and happy, but then you get some bigger values being passed in and you realize it's n squared and you're burning a lot of CPU time. It's great if you know ahead of time that this could happen for this particular for loop, but you probably have a lot of for loops and a lot of nested for loops in your project. And in order to get coverage on all these unknown unknowns, I think profiling is really the only way to sort of do that. Another angle is resource consumption. If you just like see high CPU and you just want to know the answer, it's good. Similar for memory to break down memory usage. So I think from the get-go, that proposal was met with a lot of interest, but at the time, the OpenTelemetry project was still busy wrapping up, I think, either the logs or the metrics signal that was new at the time, so there wasn't a huge interest in starting another track. But then Morgan McLean in June 2022, he's one of the founders of OpenTelemetry, proposed to go ahead and start talking about profiling more seriously, because those other profiles, signal types had started to settle down. And so there was this first meeting in June. And the first meeting was attended by a lot of people. I think there were over 100 people in the meeting. And that was really exciting and there was a lot of energy, but we were also glad that the next meetings turned out to be more that for like 10 to 20 people, sometimes 30 people, which is more manageable for a group of people to make progress together. And yeah, basically ever since June, we had bi-weekly meetings, 10 to 20 people, different companies being represented, Elastic, Grafana, Google, Red Hat, Polar Signals, Datadog, a few others I'm probably forgetting, but a very diverse set of companies that are interested in profiling, either because they do it a lot internally or because there are vendors for profiling as a product. Also, some of the people attending are users and not directly associated with any of the big vendors in the space. So for a while, we were discussing what the profiling signal should look like, and there were a lot of discussions around the existing formats. Somebody in the community, Mark Hansen, actually has a website called Profilerpedia, where he listed out that there's over 100 different existing profiling formats. But I would say for the most part, two of them are very important as a community right now. One is pprof and one is JFR. JFR is Java Flight Recording. And pprof is the profiling format that was introduced by Google initially in the context of the Go runtime, but it's also used by Google in other facilities, and other projects have adopted it. And so, yeah, initially we were trying to figure out what do we want to do. We put out a profiling vision OTAP to just outline sort of the high level goals we have as a group already in September 2022. The main ideas there, we wanted to have low overhead, and we wanted something that the collector can work with. And it took us actually a while to get there, because there were competing ideas in the working group for what the signal should look like. But we eventually converged on what we would come to call pprof extended. And the idea was, we actually like the way pprof works for the most part. You take profiling data collected over a time period of, let's say, 60 seconds, and you bundle it up in a file that essentially aggregates by stack trace. So you have a stack trace and how many times you've seen it, or mutex contention and how much cumulative time has been spent in that mutex. And then you send this up on a regular interval, like once every minute or something like that. The competing model for that was a more stateful model where you would send a stream, but in order to interpret it, you would have to see all the messages before. We eventually settled on the pprof model, and we were just saying, like, yeah, we like what pprof does, but what are the things that are missing to make this really an OpenTelemetry native format? Because OpenTelemetry has a protocol called OTLP, and I think OpenTelemetry line protocol is what it stands for. And it's basically a gRPC protobuf protocol that defines the data as it has to look like when it's ingested by the collector, or at the very least, what it has to look like to some degree in memory when the collector converts it, because the collector also has these receivers that actually is that are capable of receiving lots of different formats. But then the in-memory formats, the PData format, usually closely mirrors what the OTLP protobuf format defines. So what we found was missing from pprof was first-class support for linking to other signals. In particular, we wanted correlation between tracing and profiling, because one cool thing you can do with profiling is you can take a slow request and you have the data from distributed tracing on the request, and then you have the profiling data for the same machine at the same time. But now every time you collect a sample in the profiler, you can actually figure out, is that Go routine or that thread currently processing a span? And if yes, can I get the span ID and trace ID? And now you can actually make a correlation. But to make that happen, you actually need a field in your protocol to put the span ID and the trace ID on the samples you collect. And that was missing in pprof. At least there was no first-class field for it. You can always have labels in pprof to do these things, but that was deemed to be a little bit too haphazard. And so, yeah, we added that. And then there were a bunch of ideas to actually improve on the pprof protocol by changing the way stack traces are encoded to be more efficient in some cases. And so we put out all of that in OTAP 239 in February 2024. And that actually kicked off a discussion on whether or not it makes sense for sort of OpenTelemetry to extend pprof or not, or if the pprof project and OpenTelemetry should merge. There were a lot of discussions between people on the community side, as well as people at Google. Google's the current owner of pprof when it comes to copyright and possibly trademark. And there was actually, Google was open to the idea of maybe donating pprof, but then the more we looked in the details, the more it became clear that for Google's internal use cases, the things we wanted to add didn't seem to really make a lot of sense. And there was not a lot of interest in, pushing those changes into the internals of Google. And on the other hand, the OpenTelemetry project also didn't want to agree to make only very limited changes and to not extend more in the future, because the whole point of OpenTelemetry defining its own protocols and formats rather than adopting existing standards is that freedom of making changes based on the needs of the OpenTelemetry community. And so, yeah, that actually caught us in a limbo between February and August this year, where we couldn't quite proceed, but this was resolved in August. The decision was made to be pprof convertible. So OpenTelemetry's profiling format should always be compatible with pprof in the sense that you can take a pprof and convert it to OpenTelemetry, and maybe to the extent possible also the way back, but that will depend on the additional data we're starting to capture with OpenTelemetry. But either way, you should be able to have a pprof receiver in the collector, so you can always receive pprof as a format and not lose data in the pipeline as part of the conversions. So now we're actually in a really good place to make forward progress with the protocol. It's still in development stage right now. It used to be called experimental. It's just been recently renamed to development. And hopefully it will graduate in the coming months, but it's sort of hard to predict the timelines on that. The other exciting thing that happened in OpenTelemetry Profiling as all of this was happening is Elastic donated a profiler, an eBPF full host profiler that came to them through an acquisition of a company called Optimize. And what they had done is built this very exciting technology that actually does profiling by putting an eBPF program in the kernel and then asking the kernel that every time a thread or CPU core used up a certain amount of CPU time, that eBPF program should be notified and triggered. And then that eBPF program can actually figure out how to take a stack trace and makes that stack trace available to user space program again, which is the eBPF profiler, and uploads this data. And this is really amazing because the eBPF programs that were engineered by the people at Optimize and now Elastic are able to do this for all languages. So you can install this profiler once on a host, and you can get CPU profiling for dynamic language, high-level languages like Python, Ruby, PHP, JIT-compiled languages like Node.js and Java, but also native languages like Go, Rust, C, C++. And that is very versatile, like to have one profiler that can sort of profile them all. Of course, it comes with one caveat. It is only CPU profiling. So if you want to do memory profiling or off CPU profiling, currently there is no support for that in the profiler. But I would guess the future is bright, because now that this is an OpenTelemetry project, there's a large amount of interest in from companies that want to contribute to it. Datadog is one of them. We are very interested in this. Polar Signals has already come out with a blog post that they're adopting this eBPF profiler as a new base. So I think you will see several vendors contribute to this new profiler, and it will become more powerful over time. If it will ever fully catch up with runtime profilers for everything, I'm not sure, but I think the gap will close directionally in the future. And yeah, so the future now looks like we need to wrap up the development of the protocol. And because we have this eBPF profiler, we also need to think about a new protocol for uploading symbol information, because for native applications, you sometimes deploy them without debug symbols on the host. And so in order to actually understand what the function and file names are, you need a way to channel that information, that mapping of program counters to this debug information to a backend. And for OpenTelemetry, it only makes sense to have the eBPF profiler as an SDK if there's also a channel to send that debug information upstream. So that is something we're just starting to tackle. But yeah, I think now all the blockers, all these things we couldn't agree on are out of the way, and we're making rapid progress.
Awesome. Really appreciate all this this history class on profiling OTel. I think I was on the community meeting where Morgan brought up what would be the next steps of OTel, and we voted. It was in KubeCon Valencia, where we voted that profiling should be something to invest, and I think that was when it started this triggered this second round of discussion. So it's really great to see how things are coming along. But now I imagine like Pablo working on Collector road to 1.0, and then profiling arriving as a truck out of the blue, and like, hey, okay, so now we have this new signal, and I know that you all are working on towards Collector 1.0, but now let's add this new thing. So Pablo, how were the challenges that you faced there whenever profiling came into play, and now you have to consider also a new signal in a tool that was kind of almost ready to be GA?
Right. So that was definitely interesting. Yes. I mean, one of the challenges was that the collector can be used not only as an application, which is its most common use, but also as a library. We see some vendors using it, such as Datadog itself. Also some open source projects like the Jaeger project, which is a tracing backend. And so we hadn't really designed this set of libraries, the collector itself, in a way that could signal in a clear way which parts were experimental, like profiling is going to be for some time still. These other parts that we are marking stable, it was hard to separate the two. For the past couple months, I have been working with an engineer from Elastic, Damien Mathieu. I hope I'm pronouncing their name right. I'm not French. And so we have been firstly figuring out how to make this separation clear in both worlds, both if you use the collector as a library and also if you use it as an application, and also just the work of adding the support for this new signal, making sure that you can create components that have support for profiling, making sure that existing components can be added support. So just this morning, I merged the PR adding support for the very first component to have profiling. And in the coming weeks, we hope to announce this very initial support for profiling in an experimental way, just the bare bone basics of you can put profile data in and you can get it out of the collector. And so this would potentially be quite useful for, say, vendors or other people that are working on adding support for profiles in a backend, and also for the profiling SIG more generally to do their testing.
Awesome. So just continue on with you, Pablo. Would you I want, of course, bring Felix and Pablo into this discussion because I think that's why I invited both of them here. But let's start with Pablo. So Pablo, you work at Datadog and you contribute to OpenTelemetry, which is an open source tool, and it has like multiple vendors working together. What are the challenges that you face on those two worlds? How those two worlds get along? So like your Datadog side and your OTel side, and what are the main challenges that you face as an engineer?
Right. So I'd say that two more important challenges are, well, first that there's so much to do within OpenTelemetry, and so open source more generally, you can invest as much time as you want to into it. As I said, my main focus is the collector. We have the collector 1.0, we have collector profiling. We also just have to keep the lights on and like continue with the work that a lot of people were already doing that are not these two big projects. Well, as I said, I also invest some time in other parts of OpenTelemetry, like semantic conventions or the contributor experience. And so, yeah, it can sometimes be challenging to organize my time to make sure that, I invest the appropriate amount of time to keep the project healthy and running. And I also keep on working on the internal Datadog stuff. Recently, I've been mostly focused on Collector 1.0 because, well, we really want to make that happen. But yeah, that's been a challenge for as long as I've been contributing to OpenTelemetry for like the past 4 years or so. And the second one, which it may not be unique to OpenTelemetry, but one thing that I can see like a stark difference with like if you work on Datadog is that we have much less visibility into what our users do. We depend on our users telling us what they are doing and what problems they are facing through, say, GitHub issues or on the Slack channels that we have. And so, yeah, that brings a challenge in that we have to design things in a way that keeps a lot of doors open in the future, and like we can adapt to any situation that may come or any feature request that we may consider. So that has been interesting, learning how to deal with that and how to design things in such a way. It's a challenge that, yeah, I think many other folks in software don't have to that extent.
Cool. On that point, regarding the feedback on or information on how the end user is actually using OTel, I just want to take the opportunity and give a shout out to the end user special interest group, because they run frequent surveys and collect feedback from the end users. So this really helps us internally, and I would say us at Datadog, but also the whole OTel project to like have a future as a project. So yeah, thanks for that. And how about you, Felix? What is your perspective on that?
Yeah, so when it comes to sort of the challenges of working on both OpenTelemetry and Datadog, I think one is the general challenge of wearing many different hats. Datadog itself is many hats, and OpenTelemetry is different hats. So at OpenTelemetry, I'm working on the profiling special interest group, but I've also been added as a maintainer for the new eBPF profiler. And so I'm at one point thinking about the protocol, at another point thinking about the technology that's going to produce the data, and both are relatively deep topics. But then at Datadog, I'm also wearing many hats. I'm contributing to the Go runtime upstream, which actually interfaces with OpenTelemetry as well, because the Go runtime is one of the primary producers of pprofs in the community. And so I have discussions with people on the Go team about what OpenTelemetry would like to do with profiling and how the Go runtime could eventually support that without potentially paying high overheads and converting the data to get it out. I'm also working on the profiling team, so I'm thinking about features to build in the Datadog product. I work with our APM team, which is doing distributed tracing because we have a tight integration between profiling and tracing. I help other teams like dynamic instrumentation. I work on the client library teams and support them in making sure our repositories are well managed and we're putting out solid releases. I'm working on internal optimizations, and I'm also trying to talk to customers. So it's really just like, which block in my calendar that has a little bit of free time am I going to use for what, and what are the important things to focus on? Because I can't do all of these things at the same time, right? Like I have to say, like right now I'm focused on this area, and then trying to have as much impact there as possible. So that's a general challenge. I'd say specifically in the OpenTelemetry working group, one challenge has been to balance the needs of Datadog against the ideas that other vendors bring to the meetings, and of course also the end users and community of OpenTelemetry. So one good example would be that I mentioned in the beginning of the profiling special interest group, we had a lot of debates on whether we want a stateless format where you basically just have a self-contained payload that represents one profile, or whether you want a stateful stream where you essentially have to see the whole stream in order to understand what's going on. If you just tune in the middle of the stream, you'd be lost and you'd be missing symbols and other information. And that one was tough because Elastic, they were pushing for that. They actually made really good points on why their approach, which was very different from what others had done, was also very good, and it had different pros and cons. And so at some point, like I had to balance the needs of what's easy for Datadog to support in the future, because obviously you want to support the OpenTelemetry signal that's going to arrive, but also what's going to be good for the OpenTelemetry Collector, which is a system in the ecosystem, but then also what's going to be good for users when it comes to debugging things when they go wrong, when they want to have the main thing of OpenTelemetry, the data portability. At the end of the day, if something is more complex to implement on the backend side, it's going to be supported by less companies and less open source backends. So all of these things sort of need some balancing, and that has been a challenge. And then last but not least, committee work in general. Because in a company that can already be challenging to work with a large group of people, but when you have an open community that works in a committee together, you have people come and go, you know, so like you have a bunch of people discussing something, then next week that person you wanted to really follow up with is not there, but a new guy comes in and brings up the ideas that you actually discussed 2 meetings ago, and you go back there, and so you get pushed and pulled back and forth. And yeah, you cannot always control where the puck is going and what's currently going to be the topic of any given meeting. And so yeah, you have to be very patient and resilient against little frustrations in the process. It will all come together in the end, but it takes everybody to bring the A game when it comes to communication and trying to collaborate together. So yeah, I would say this is a summary of the challenges.
I 100% feel like that's That's something that I've also had to deal with, like the seeking consensus with a large group, and it's something that with the collector 1.0 we've seen a lot of that.
Awesome, awesome. So now to wrap up our conversation, we already have a couple of questions, which is good. But I want to wrap up here, getting your takes on what is the future of OTel. What do you see as a future? So let's start with Pablo. Pablo, once the collector 1.0 is there, what do you expect of the project? What do you expect to you as a contributor to it?
Right. So the main thing I want to see is to build more of an ecosystem around the collector, both within, say, the OpenTelemetry org, but also outside of it, and have people build cool new stuff with this core stable foundation that we are providing them. So yeah, make it easier for people to build new components for their own use cases, make more of the components that we have go 1.0, try and have some easy way for people to find them in, say, our website. And then the second one, well, within the collector specifically, I think we want to keep on supporting the new improvements and new tools that the other 6 are working on. For example, it's in the very early stages, but there's another special interest group working on entities, which would be a new signal. So this is another signal that we'll have to support in the collector, build new components that gather useful information about your infrastructure, your processes, your containers, adapted to this new signal, and make it all work together nicely. Keep up the good work that we've been doing for a lot of years now. Well, maybe not a lot, but like quite a few.
Awesome. What about you, Felix? Let's say in a couple of months or in a year or so, we have profiling signal stable. So what is your next step on the project? What do you expect, and what is the future for you on the project?
Yeah, so I would say the most exciting thing about having a signal standardized in OpenTelemetry is that it opens up a potential ecosystem of people implementing SDKs and profilers in the case of the profiling signal, because there's a lot of ideas to explore in that space. There's a lot of ways to produce profiling data. The eBPF profiling that's just been donated to Elastic is really great. But there's also many other languages that would benefit from really good runtime profilers that maybe currently haven't taken off yet because there's no standard way to send profiling data anywhere and use it in production. And with vendors like Datadog, as much as we've built really good client library SDKs, we're never going to build SDKs for the most niche languages. And so, for example, we had one customer that implemented a profiler for Julia, which is relatively niche language. It's a very nice language, but that rarely happens. Like, I'm telling you this because that's crazy. That almost never happens. What happens a lot is once you have a community, then people who love different languages and runtimes, they'll come together. They'll do profilers for Erlang. They'll do them for Julia. They'll do them for SIG, for any sort of smaller languages. SIG is a bad example because it's native, so it's probably going to be handled by the eBPF profiler. But you get the idea. There's an ecosystem blossoming, which you can only get with something like OpenTelemetry. And the future looks very bright there. I think the eBPF profiler is going to gain a lot of capabilities. It might manage to evolve beyond CPU profiling. I really think the only challenge in the long run is that once something gets standardized in OpenTelemetry, it just gets a little bit harder to innovate and change because it's very painful to change protocols, to make bigger changes to what's required and what not when you're sending data. If you're making compromises, you're just saying like everything new is optional, then basically at some point the receiving end cannot assume anything to be there, and the user experience will often suffer as a result. At the same time, if you're too strict, then a lot of existing ecosystem is going to be left behind because those components are not going to be compatible anymore. So evolving the future on the protocol side will always be tricky. But yeah, I think the future is going to be bright. eBPF profiling is something we're going to support also at Datadog. If anybody is listening and is interested, we're about to open up our private beta. Feel free to reach out to get onboarded to that. And we're also working on intaking OTLP data directly, given, yeah, basically which would allow any future OpenTelemetry profiler to be compatible. So yeah, that's my thoughts on that.
Awesome. Yeah, really appreciate Pablo and Felix, your time and availability to join the call and share the takes on the project and what you guys are doing. So as I said, we have a couple of questions here. I want to go through them and discuss a little bit with you all. I think I can actually start with this one for Felix. So Felix, Vishal asked, what impact will eBPF have on OTel? And I think as you are involved in eBPF, you can maybe
I guess we already talked quite a bit on eBPF profiling, which I think will have a good spot in the OpenTelemetry system. But eBPF is a technology that's exciting for observability in general, I would say, because it allows you to look in parts of the Linux kernel that previously have been hidden away, but it also allows you to directly instrument parts of applications, especially native applications that were previously hard to instrument. So I think it's going to play a role for both profiling as well as distributed tracing and maybe even logging. It's hard to say where it's going to really get the most traction outside of profiling, because one challenge if you're trying to use eBPF to, for example, do distributed tracing is you need to know exactly where to put your probes, the so-called U probes. And there's various techniques to do that. But if the program changes and the function names change, then your program that's doing the instrumentation has to be updated. So it's a very delicate dance of keeping a sort of eBPF instrumentation in sync with an evolving runtime and application. I think another cool area, which I don't know if OpenTelemetry is already looking into that as a new signal, but dynamic instrumentation, where actually the user at runtime decides where they want to put probes to basically produce dynamically like a log statement or metric or a distributed trace span by basically just at runtime doing it similar to a debugger just in the cloud, which is something we're already doing at Datadog. And I think that could be another area where eBPF and OpenTelemetry could make a really good connection. For profiling, I see a strong future, especially CPU profiling. That's going to work really great. For memory profiling and off CPU profiling, we have some ideas, but we'll have to see. One challenge is overhead as well. Every time you fire eBPF uprobe, you have to switch between userland and kernel. I know there are some userland eBPF runtimes as well, which might help with that overhead. But generally speaking, there's a lot of engineering challenges ahead of us with eBPF. But eBPF is here to stay, and I think it's going to find more niches where it's going to work really well over time. And OpenTelemetry is absolutely part of that.
Awesome. I have, I think, one question here that Pablo can take. So if there is an issue with OpenTelemetry auto instrumentation, or OpenTelemetry agent or the collector, will Datadog help resolve the issues as it is open source?
So we have people involved in a couple of auto instrumentation SIGs, specifically, I believe in Go and .NET. And well, we have myself on the collector and some other folks. If a customer needs help with something related to these areas, and we have expertise on this, we can help them either put them in contact with the community and the appropriate person, or potentially solve it if we have the skill set in-house, so to speak. we do take feature requests and back reports from customers and do the work of helping them move them forward. So it would depend on whether we have expertise, but I guess the answer is we will help you. Yes.
I just want to bring a case that happened a couple of months ago where we had release 102, I think, was where we had the security issue, and the community worked really fast, and I think you were involved in the fix of the severity.
Right. Yeah, I was part of
release.
the remediation reviewer group, and I also help on coordinating the blog post and communications. So yeah, that's a good example. I can think of other examples where we have fixed bugs for customers that were upstream in the collector or in one of the language libraries.
Awesome. Cool. Okay, there is another question here. I think we still have a couple of minutes. So I think that we can have a discussion with Felix, Pablo, and myself. Is there a need to deploy Datadog agent anywhere? What will we miss if purely use open source OTel other than the agent or in the collector? So I think mainly is like if I use just OTel or if I use Datadog with OTel or just Datadog, what are the things I'm missing?
Right. So maybe I can start with differences between the agent and the collector. I mean, there is some. I guess I should mention the obvious thing, which is that there is some common ground between the two, which is a project that part of my team is working on with adding support and convergence between the Datadog agent and the OpenTelemetry Collector, so that you can run a Datadog agent with a collector, and you can use your collector configuration in the Datadog agent and have the best of both worlds. You may not have every single component that is out there, but you will have a curated set that should cover most use cases. There's the option to go full pure OpenTelemetry. In that case, you may not have access to some of the features within the agent that are not standardized within OpenTelemetry. Data has been here for a long time, so there's a lot of products that we support that have not made their way yet into OpenTelemetry. But you will get some more flexibility in terms of, say, processing your data in the very specific way that you want, and using components from the community.
Felix, anything to add? I mean, as of today, you would get profiling and security insights, but anything else to add?
So, yeah, in the short term, profiling is something that is only available with the Datadog agent right now, just because the OpenTelemetry signal is still in development, but that's going to change soon. Then for the foreseeable future, the difference is going to be that OpenTelemetry will be limited to CPU profiling, whereas with the Datadog agent, you can use the runtime profilers that we've invested a lot of work in, which allow you to go much deeper, be it off CPU profiling with our timeline feature, or be it memory profiling, contention profiling, lots of stuff. Maybe the connection between tracing and profiles is another important one. But I would imagine that gap to close over time. In general speaking, I think the sweet spot for deployment is going to be what Pablo mentioned, the conversion collector, where you have a Datadog agent that has a collector inside, and you will always be able to use OpenTelemetry for everything where OpenTelemetry has a good equivalent of a Datadog feature. And for everything else, you can decide to opt into agent features when you need them. And yeah, as far as the future goes, OpenTelemetry is developing rapidly, so directionally, I could imagine the feature gap between what you get with the agent and OpenTelemetry to close over time, but we'll see how that plays out depending on where the community invests time and also what Datadog puts out in terms of new things.
Awesome, cool. I don't know. Well, we haven't discussed that in the episode, but how to ensure that OTel spans have the correct parenting structure in complex applications, especially in the context of async calls. So I would I need to, if you could send your contact in the chat or as a private message. I have a talk to give as a reference for you at the last KubeCon, where we discussed async calls and how to do that. So I really recommend that whenever someone brings that topic. But mainly they were advocating on linking the span. So as you never know when the child will, so you send a message and you never know when that message will be processed and consumed. Whenever a new span is created to consume that message, then you just link with the parent. So then you can navigate in Datadog. Now you can navigate from the parent to the child and from the child to the parent. Well, they're actually not. It's not a relationship of parent and child anymore because they are just linked traces. So you can navigate between those two linked traces. But the important thing is that you can then see them linked together, which will give you a nice overview of your trace. Anything to add there, Felix, Pablo? I don't know if it's your area on that.
I don't think I have much to add to.
Yeah. Okay. So, and there's one last question here. I guess BPF-based CPU profiling is more mature for compiled languages like Go. Do you folks have any insight on how far the OTel profiling signal or the new donated profiler is usable for runtimes like Node.js? I heard something showing JS function names, stack unwinding is more complicated due to JIT runtime, but don't really know any details. Is there any blocker for the Node.js runtime itself for eBPF-based profiling?
Yeah, to answer the Node.js question directly, the OTel eBPF profiler does support Node.js, despite it being a JIT compiled language and more complex. It is not supported on ARM64, so it's only Intel 64-bit where Node.js is supported. I suspect that's because it's a lot of work to support a JIT with eBPF profiling, and ARM support needs somebody to make time to do it. Generally speaking, the way the eBPF profiler works is pretty wondrous in the sense that it really has to know a lot about the internals of the languages that it's trying to profile. And as those internals are changing over time, the eBPF profiler needs to be kept up to date. The community experience with that is limited right now because it's just been donated. The folks at Elastic have said that they had a relatively good time with keeping the code base up to date over time. I think now that the community is behind it, that there's a higher chance of that working out for everybody because a lot of people will contribute. So I would say the eBPF profiler is usable for runtimes like Node.js and JIT runtimes in general. But if those runtimes decide to change their internal representations and their compilers every couple of months in the future, it might get interesting. But I think that's relatively rare because at this point, V8 and other JavaScript JITs are relatively stable, I would say. But we'll see what the future holds.
Awesome. Cool. So we went through the Q&A and right on time. So I want to say thank you for Felix, Pablo, and everyone that joined and participated. As I mentioned at the beginning, this episode is it's recorded. There is some post-production, but it will be live afterwards on datadogon.datadoghq.com, and you can rewatch and share with your team and someone that wasn't here. And also, all the previous episodes are available on that page, so make sure to check them out. Thank you, everyone.
Thank you.
Thanks for having us.
Thank you. See ya.